Okay, we've got an identity to prove, and we always start with the side that looks more complicated, and in this particular case it's definitely this. Now what do I think I can do with this? Well, I've got sine of an addition and I've got cos of an addition, and I know addition formulas. So the formula for sine of x plus 45 degrees, okay, you'd be best off actually doing this yourself. Look it up, put the values in, see what happens. Go on, do that, pause it, come back when you've done that. Okay, so you've done that. So sine of a plus b is sine a cos b. So that's sine x cos 45 degrees plus cos a sine b. So that's going to be plus cos x sine of 45 degrees. And similarly, cos of x plus 45 degrees is cos x cos of 45 degrees minus sine of x sine of 45 degrees. That is just a basic use of your addition formulas. Okay, now all of these cos and sines of 45 degrees, this question depends on you knowing the exact value of that, or failing that, cheating on your calculator. Now your calculator thinks that sine and cos of 45 degrees are root 2 over 2. So maybe that should be the formula I use. In fact, there's an equivalent form to that, which will probably make this drop out easier. But you know what? I'm going to assume you're cheating on your calculator rather than using knowledge of the equivalent form. So what would you get? You'd say, for every time I see a cos of 45 degrees or a sine of 45 degrees, I can write root 2 over 2. So I'm going to get sine x times root 2 over 2 plus cos of x times root 2 over 2 plus cos of x times root 2 over 2 minus sine of x times root 2 over 2. Now this term here is exactly the same as that one, but this has got a minus on it, so this is going to cancel with this. Okay, and this one here, oh look, I've got something divided by 2. Cos of x times root 2 over 2 is the same thing as, okay, so cos of x times root 2 over 2. You've got to be comfortable. I could write cos x is cos x over 1, so it's cos x times root 2 all over 2. Okay, so this is cos x times root 2 all over 2. This is cos x times root 2 all over 2. So I'm adding something, half of something, to another half of that same something. So the answer is root 2 lots of cos x. So I've got half a root 2x here and half a root 2x here. So the answer is root 2 cos x. Oh look, which equals the right hand side. So let's put this in the form for an identity. Left hand side equals this. I've not cheated, I've got to the right hand side. Therefore, left hand side equals right hand side. And we're okay. All right. So, all right, next example is really just the same thing. You're going to need to know sine and cos of pi by 6, which your calculator will give you an exact value for. But you know what? I will do another video on example 3, but I want you guys to go away and use exactly the same method and see if you can prove this without, well, I mean, it's not an identity, it's getting a value of tan x, but start from this and end up with an identity that ends with tan of x equals something. You can do it. Do it. Look at the other video to check.